take animal nutrition. Most of these chapters are going to be pertaining to human anatomy and physiology. But every now and then we're going to slip back and talk about other organisms because this is not just a human anatomy and physiology class. We're going to be covering a lot of things. 3 dietary categories of animals. Herbivores are plant eaters. Things like cows and other things that just munch on vegetation. Some of you might be herbivores, otherwise known as vegetarians. Carnivores are the meat eaters, the cats, the dogs, these guys. And then you have a group of organisms that are a little more opportunistic. They'll eat both plant and meat material. Raccoons is a good example. What are some other good examples of omnivores? Humans. What else? Bears are omnivores. Crows are omnivores. What else? Dogs, coyotes, wolves can be omnivores. Cockroaches are omnivores. A lot of rodents are omnivores.
Are primates? There's some like...
Some are. Some are strictly vegetarian. Others can be omnivorous, eating both plant and meat material. Yeah.
How many species eat fungus? How rare is that?
I don't know. I've wondered that too before. I'll look that up sometime. Outside of humans, I don't know if anything else eats decomposers.
Yeah.
I know, if you think about it that way.
Yeah.
People up around the Great Lakes are trying to figure out how to get rid of the lamprey. And they'll have these big lamprey festivals, or at least they tried to. And they tried to have a contest to come up with different dishes for fixing and eating lampreys. And yeah, that didn't go over real well. Not a lot of people out there want to eat parasites either.
Yeah.
Okay. 3 nutritional needs of animals. 1, you need it for fuel, chemical energy for all cellular work. You get up in the morning, you skip breakfast, and it seems like you just cannot get kicked in. You're just dragging all day long, at least until lunch. You eat a little something, then you've got energy, you feel a little bit more empowered, ready to go and take on the world. Raw materials, carbon skeletons for biosynthesis of all organic materials. We take things in, we break them down, and reassemble them as to how we need them. We're going to talk about some things that your body can make, other things you have to get in your diet. Essential nutrients. Substances that an animal cannot make for itself. So, regardless of your diet, if you're an omnivore, you take in most stuff as long as you eat a balanced diet. If most of your diet consists of burgers and pizza and stuff like this, chances are you're not getting everything you need. If you're a vegetarian, you have to make sure that you supplement the protein that you're not getting in meat with plant protein, the right kind of protein. So fuel, raw materials, and essential nutrients. You want to go for a run, you think you're going to McDonald's, get a Big Mac, take a 2 all beef patty, slap on your thighs, and you're ready to go. It doesn't work that way. It's going to take down whatever meat is in there, break it down to its amino acids, and assemble it into the proteins that your body specifically needs. And of course, it all comes down to cellular respiration. This is why we need that fuel. We need to power all of our cells, and that's broken. The food we take in is broken down into the components we need, mostly carbohydrates for cellular respiration, and then it's absorbed from our small intestine into the circulatory system and carried to all the different cells. And remember, cellular respiration is the process in which ATP is generated in order to power basal metabolism, physiological activities, and thermoregulation in endotherm. What's an endotherm?
Warm-blooded animal.
Warm-blooded animal, either what or what?
Okay.
Warm-blooded animal, either what or what?
Mammal or bird?
Birds or mammals. Yeah, not just humans, but all mammals. All of us. There's a picture of the cheetah up there. It's one of the best examples of cellular respiration in action. Burning tons of ATP over a very short period of time. But even after the cheetah accomplishes its hunt, whether it's successful or not, it has to rest, it has to recuperate, it has to rebuild its energy stores before it eats or goes out on the hunt again. So we've had this, don't worry, we're not going to fall back into biochemical pathways. We're just mentioning it as part of the digestive system. Carbohydrates, lipids, and proteins. Carbohydrates we eat is a quick energy source. Most of it is burned. Whatever is not burned is stored. Talk more about that later. Lipids are for long-term energy storage. So a lot of times carbohydrates will be converted into lipids, so we have them just in case. Proteins, last resort energy source after carbs and lipids have been exhausted. You might remember the Atkins diet, or the no-carb, low-carb diet, where you pretty much cut out carbohydrates. Unfortunately, that's all the good tasting stuff. And when you start cutting out stuff, denying yourself things, that's what you want the most. So you cut out the carbohydrates. Then what happens is the lipid stores in your body begin being broken down. And as they're broken down, that's how people lose the weight. Now, let's say you burn through your carbs, you burn through your lipids. And so you're going to take yourself on a cruise because you're just happy with the new you. And the ship goes down. And you end up on a deserted island with very little, if any, food. So no carbs, no lipids. Next what's going to happen is the body's going to start breaking down proteins. So carbohydrates, quick energy source. Lipids, energy storage. What did we say proteins were for?
Everything, enzymes.
Structure and support, right? Everything about how you move and basically the workings of your body. You start tapping into that, you're tapping into the foundation of who you are. And you're touching into things that don't need to be touched. This is where you're starving or you have something like anorexia. Yes?
Can like diets that are overly high in protein hurt your kidneys?
Yes, because you only absorb what protein you need, which is relatively little. And so if you're throwing down more protein than you really need, it's all going to be lost to waste, and it could overwork your kidneys, and you could have kidney problems. Sometimes, let's go back 1700s, gout was pretty rampant. It's a condition where a lot of pain in the joints because they were eating such high protein diets or protein rich diets that the kidneys couldn't process everything and protein crystals were building up in the joints, making it very painful. You hear about that every now and then today, but not so often. We don't tend to eat as much protein as they did.
How long can lipids be stored?
Indefinitely. How long can they be stored? Yeah. That's why we're an obese society. Because we just keep storing and storing and storing lipids. It's not like, okay, these lipids have been here for over a year, about ready to expire, let's get rid of these and put in new ones. They just keep adding on. The hummingbird, almost a purely carbohydrate diet, but because of high metabolic rate, burns through everything. Again, that's why you don't see fat hummingbirds. Black bear, you see this guy's put on a little bit of weight here. It's a her with cubs. But in the summer and the fall of the year, they start engorging themselves on whatever they can find to eat, becoming omnivorous, opportunistic, because they're going to shut down for a while for the winter. We talked about this last time. Semi-hibernatory state, a little bit of hibernation going on, so there's not going to be a lot of food available, and they just build up and store it so their body can gradually break it down. When glucose is not used, it is converted into glycogen and stored in the liver. Excess glucose, that which is not converted into glycogen, is stored as fat. When needed, glycogen can be converted into energy. If you've got a big race coming up, swim meet, track meet, whatever, you might load up on carbs the day before, rices, pasta, things like that, because you know you're going to burn that stuff off. And if you're right before the race, you eat a candy bar or something, but you know you're going to burn that. And your body's okay with that. The reason for this, 10,000 years ago, the world was a different place. We had a different place in the world. We weren't the top dog. We were eaten by dogs and cats. And so we're hunter-gatherers. We're out one day. We run into a saber-toothed cat. And so we run for the nearest tree and climb up the tree. And we're sitting up there, maybe for hours at a time, until the saber-toothed cat just gives up and goes away. Well, because of the instant energy we need to try and outrun the cat and to climb a tree, and then for however long we're going to be up there, we're going to burn through those energy stores. And so it was a defense mechanism that our body used to help protect us, to store up energy. Okay, now let's fast forward 10,000 years. There's no more saber-toothed cats. We are the top predator. We don't have to worry about being eaten by anything. So, what do? We are relatively lazy. We don't work out as much as a society. We go home, we sit, and we channel surf or surf the web. We don't exercise enough. We don't eat the right things. And so we just keep packing on the pounds. We keep packing on the weight, keep storing up the lipids without ever burning it, because our body's thinking, okay, maybe someday we'll run into something like a saber-tooth cat or something like that, and we'll need to burn some of this energy. So we just keep packing it on, okay? So that's why you're relatively obese. So you just have to compensate. Either you have to watch what you eat, or you have to exercise more in order to keep your weight down, or do a little bit of both. Now, I'm not saying you got to join a gym or get a trainer and start hitting the weights, doing the cardio and everything like that. Just find something that makes you happy. Even going out for a walk 2 or 3 times a week, 20 or 30 minutes, and then just adding on to that. That'll make you feel better, and it'll help. Just find something you like to do. If you join a gym and you hate working out, it's going to be like torture, and you're not going to want to do it. You're going to quit, and you're going to go back to your old ways. It's your public service announcement for the day. Undernourishment. Stores of glycogen and fat are depleted and the body begins breaking down proteins for metabolism. These are extreme situations, parts of the world where they just do not have enough food.
Like Hollywood.
Hard to tell who's losing what because of all the enhancements people do to their bodies. Brain becomes protein deficient, so it starts affecting brain, and if it's early enough in the development of the child, could lead to things like mental retardation. Muscles decrease in size because muscles are protein. And they're one of the things your body can start breaking down without really hurting the body all that much, as opposed to breaking down organs that you might need for something. Death eventually causes this stuff like starvation and anorexia. Undernourishment. You're not getting anything. Now, we're going to have 3 terms here. Undernourishment, malnourishment, and obesity. Yeah. So be aware of these, be able to distinguish them from each other. Again, as you go through, you've taken 3 exams now, you should kind of have an idea of my approach, the format. This would be a good one for multiple choice. So stores of glycogen and fat are depleted and the body begins breaking down proteins for metabolism. Again, the cause is starvation and anorexia. Obesity. This is where the body hoards or stores fat instead of using it for fuel. It could lead to things like colon and breast cancer and diabetes. Cardiovascular disease increases, whether we're talking about heart attacks or strokes. We'll talk about strokes, I think, in the next chapter, circulation. But basically, it's like a brain attack, where you have problems with blood flow. Causes: diet, sedentary lifestyle, leptin deficiency. Okay, let's start with the last one first, leptin deficiency. Leptin deficiency causes the body to store up fat. And so it could be genetic. You could actually have a genetic cause, a genetic problem as to why you can't lose weight. Diet, again, watch what you eat. If you're going to drink sodas, drink diet sodas, but you're better off drinking water or tea or something like that. Studies have shown that even diet sodas can get the body thinking that the artificial sweeteners are the same as sugars and result in diabetes and other related diseases. Sedentary lifestyle, like I said, get out, do something. I'm sorry, playing Wii does not count as activities, okay? Not physical activities. I see people sit on the couch and bowl, okay? No, that's not it. So find things to do, something you like, something that'll allow you to enjoy exercise. Yes?
What's what?
Leptin. I'm thinking, I'll have to look this up for sure. Yes.
I think it's the hormone that your fat cells release to signal to the brain that it's time to stop eating.
Yeah. It is a hormone, and what it does for the body from storing up fat. And so people who have missing the gene that allows leptin to carry out its normal functions, what happens is the body storing.
I think they think they're always hungry, huh? They feel like they're always starving.
I thought that was
Always
Kremlin.
hungry.
I thought that was Kremlin.
I think that's me.
I
I think I'm deficient in that too.
Shit, Louis.
Malnourishment, not undernourishment. Undernourishment, you're missing everything. Malnourishment, a diet missing one or more of the essential nutrients. We'll talk more about the essential nutrients in a few minutes. Essential nutrients, materials that must be obtained in pre-assembled form because the body cannot make them. For instance, ascorbic acid. Your body cannot make this, but if you drink orange juice, you get ascorbic acid. What do you need ascorbic acid for? Metabolism, specifically cellular respiration. So essential nutrients, materials that must be obtained in pre-assembled form because the body cannot make them. There are essential fatty acids that you need. Think about it. Every cell in your body is a phospholipid bilayer. Doesn't sound like much, but you've got 60 to 100 trillion cells in your body. It adds up. So your body does need some lipids in the form of certain fatty acids. Amino acids. Your body can make certain proteins from the amino acids you have, but you can't make all the proteins because you don't have all the amino acids. So you have to obtain them already in your diet. So like I said, if you have a balanced diet, you should be getting most of everything you need. So again, malnourishment, a diet missing one or more essential nutrients. Undernourishment, you're missing everything. What's the one thing most people are missing in the world? People who are starving, what's the one thing they can't get?
Food?
Well, specific type of food. Protein. We can send all the rice, all the grain over there. They're starting to enrich the rice with some protein, vitamins, things like that. But it's real protein is what they're missing the most. That's the hardest thing for them to come by.
Don't beans have quite a bit of protein in them?
They do, but I don't know if it's always the right kind, and I don't know if they're getting enough beans.
So you have to actually
Like I said,
eat.
rice, grains, lots of that. Yes. What were you saying?
To get the right protein, you actually have to eat meat.
Not necessarily meat. You can get it from your diet, but those people in parts of the world where we're trying to send food and try and help them out, I don't know if they get all the right kind of food that way. But yeah, as long if you're a strict vegetarian, hopefully you're dedicated enough to the cause that you do your research and find which foods offer you the right kind of proteins. But I think you should be able to get it from your diet. Yeah. One of the essential nutrients, amino acids, 8 of which must be obtained in pre-assembled form for the body, cannot manufacture them. Remember, we need 20 amino acids. So 12 we're okay with, but 8 we have to make sure we specifically get. Animals require 20 amino acids for protein synthesis. Protein diet enables body to manufacture 12. Sources of the other amino acids, animal products like cheese, eggs, meat, mostly a lot of the dairy stuff, and plant products. It's funny, with eggs, people go back and forth on them. One year they're good for you, the next year they're bad for you. And then they're good for you, then they're bad for you. Last I've heard, they're actually pretty good for you in moderation. Just gotta watch the cholesterol and fat in the eggs. That's why a lot of people promote egg whites, because it doesn't contain that. But they have most of the vitamins you need, with the exception of vitamin C. You have those in a glass of orange juice in the morning, you should get most everything you need.
I was just thinking that egg whites might not have some of the
They have all the amino
important
acids.
stuff that the yolks might have. You know, like the amino acids. Or
There could
No,
be
they're-
other things in the
they're
yolk
all
that
in
you might need, but like I said, everything in moderation. If you have 2 or 3 eggs a couple of times a week, you're probably going to be okay. Now, people always ask me, well, I watch Rocky and he always drinks the glass of raw eggs. Is that what I need to do? Well, think about it. The reason they do that is so you don't cook them, so you don't break down the proteins. You don't denature them, right? What's going to happen when those eggs hit your stomach with a pH of about 2.5?
You're gonna
They're
cook
going to get denatured anyway. So I say cook them, make sure they taste better, you get all the nutrients you need still, so your choice. Yes?
You can't get them all from food, is it equivalent if you like take supplements?
I think we're going to talk about that with vitamins and things like that. A lot of people do supplement their diets with vitamins and other dietary supplements. That's fine. I try and take everything I need through a balanced diet, and because you should get everything that way, but I know it doesn't always work for people. Or if you want to go above and beyond, you're working out, you need more of this, and sure, supplements are okay as long as you don't overdo anything. Because some vitamins are fat soluble, which will end up in the fat of the body, and if you take too much of it, you could become toxic in those areas. Other vitamins are water soluble. No matter how many you take, you're just going to waste it. Orange juice, vitamin C is a water soluble vitamin, so you can sit there and drink orange juice all day, so you don't get sick. But it's only going to take what you need. All the rest is going to be lost. Amino acid deficiency, protein deficiency, usually in children who are lagging in physical and mental development. So again, one of the hardest things for most people in the world to get for their diet is protein. Yes.
What causes the extended stomach?
Oh, I read about that. That's
Somebody said something.
Furry.
I can't think of the name off the top of my head.
yeah, I've heard about it.
I'll look that one up too. But yeah, it's because of a deficiency in the diet that causes their bellies to extend.
It's a protein deficiency.
Yeah. It's not very kwashiorkor, something like that. I think it's what it's
Yeah,
called.
I think you're right.
So amino acid deficiency, protein deficiency, because amino acids are building blocks of protein, usually in children who are likely lagging in physical and mental development. We don't see that so much in this country. Third world, underdeveloped countries where they just don't have the food. Maybe they're going through droughts or famines or social conflicts, they just can't get the food they need. Fatty acids, like I said, dietary requirement necessary to build cell membranes. The healthy kind to get are the unsaturated fatty acids. These are found in plant-based oils, tend to be liquid at room temperature. They have less than the maximum number of hydrogens because of a double bond. Like I said, these are the healthy ones. No, the stuff you put on your popcorn in the theater is not healthy for you. But it's liquid. It's not at room temperature though, it's hot. This is a typical straight chain fatty acid. Okay? Here in the middle, you have a double bond. When you make this double bond, you lose a hydrogen here and a hydrogen here. Hopefully everybody's following this. Have a little bit of chemistry at least. This is what makes it unsaturated. When we talk about something being saturated, it's like it has as much as it can hold. You take a sponge, squeeze it, put it in water, release it, pull it back up, it's just dripping with water because it's saturated. A saturated fatty acid has all the hydrogens it can hold. Unsaturated, in this case, it's missing two hydrogens because of the double bonds. There's two characteristics right there with unsaturated fatty acid. That you've got the two carbons with the double bond, and because of the double bond, they're each missing hydrogen. They tend to be liquid at room temperature, they tend to be plant-based. These are the healthy ones. Things like corn oil, sunflower seed oil, olive oil, vegetable oil, canola oil. All these things are healthier for you than, say, using butter.
But with coconut oil though, that's like pretty high in saturated fat.
It is pretty high in saturated fats, but it's still the plant fat. So if you go that way, it's not the best one to get, but it's still better than something like butter or lard or something.
I thought it was really good for you, babe. Coconut oil. You hear like how good it is. It's like super good. Everybody's using it.
I don't know.
Hmm.
I stick with pretty much canola or virgin olive oil. Those are the best.
Like smart balance.
What?
Smart balance is so unneeded.
It's like diet oil.
It's got like amino acids in it, right?
Okay, so it's like enriched. The other ones are saturated fatty acids found in animal-based oils. They tend to be solid at room temperature. If you look at this, here's the saturated fatty acid. You don't see any double bonds, and all the carbons in the middle have the two hydrogens. So it's saturated because it has the maximum number of hydrogens because it's missing a double bond. These are unhealthy. Those are the ones you want to stay away from. I grew up in the southeastern part of the U.S. The home of Kentucky Fried Chicken, okay? So just put it in that kind of context. My family, typical Southern family, where everything was fried. Not just like eggs, not just like chicken. You get chicken fried steaks, fried pork So much so to the point that after you got done frying, you take the grease, put a little coffee can on the stove, and it would harden. So the next time you cook, you just took that out, put it in your pan or your skillet or whatever, and you would just use that over and over. And of course, being from the Southeast, everybody in my family smoked as well. So we've got poor diets, smoking, and of course, nobody ever exercised. So some of my relatives reaching their 70s and 80s was pretty phenomenal, especially after the bypass surgeries, the emphysema, the whatever.
Yeah.
So I figure, because I don't smoke, because I eat healthier, because I exercise, I'm good for about 120. 120. We'll see. So, unsaturated fatty acids good, saturated fatty acids bad. Vitamins. We're going to talk about vitamins and minerals. Minerals are simple inorganic molecules. Vitamins are organic molecules. That's the big distinction between the two. Because the rest of the definitions will be similar. Vitamins are organic molecules required in small amounts, preventing deficiencies which could result in severe problems. 13 essential vitamins for humans, most found in a balanced diet. That's again why I have the eggs up here. You get most of the vitamins you need out of eggs. And like I said, the one that's not there is vitamin C. Glass of orange juice, you're good to go. Linus Pauling, a famous chemist, advocated vitamin C was the essential vitamin to cure all ills, including cancer. And if you take enough vitamin C, a lot of people load up on vitamin C when they're sick. Not just orange juice, grapefruit juice, lemonade, tomato juice has a lot of vitamin C in it as well. So you can drink a lot of different sources, but again, it's a water-soluble vitamin, so whatever your body doesn't use is going to be lost through urine. Ironically, Linus Pauling died of cancer. So if you eat a balanced diet, which most of us do not do, you get all the vitamins. And so whatever you're missing, you can supplement with, what do you guys take? 1 stone chewables or something like that?
Those were so good. In a big ball.
I like the gummy bears.
Yeah, I like the gummy vitamins too. Okay.
Now, keep talking about the water-soluble and fat-soluble. Water-soluble, easily dissolved in water and are excreted from the body. Vitamin C. And again, talked about ascorbic acid being used for metabolism. Vitamin C itself is good for connective tissue production. If you're thinking, what's connective tissue? Tomorrow we'll cover that. A lot of the important tissues in your body are connective tissue. Bone, cartilage, adipose. Water-soluble, easily dissolved in water, excreted from the body. Vitamin C is an water-soluble vitamin. Fat-soluble, absorbed through the intestinal tract and can accumulate in the body. Too much and you can become toxic in certain vitamins. Vitamin D, it's good for calcium absorption and bone formation. This is why they tell you as little kids, you need to drink your milk for strong bones and strong teeth. But vitamin D helps with calcium absorption and bone formation. Anybody in here still drink milk? Some, few, not all. It is kind of weird if you think about it.
So
All the
weird.
animals in the world, one of the few that adults can still drink milk. What? No, it's not even our milk.
Yeah, that's
Thank goodness
gross.
for Louis Pasteur, it's pasteurized. Otherwise, we'd all have cows in our backyard or goats or something, huh?
What if you could go in the grocery store and buy buy human milk?
What'd you say?
What if you could go in the grocery store and buy human milk?
Ew.
Why is that grosser than
I don't know.
cows?
I don't know. There's a whole Friends episode about this. It's just something that's just hold on a second.
I was gonna say they actually do sell vegetables.
Yeah, but at the grocery store.
They actually do sell it.
Where? Not that I'm gonna run out of line.
I don't know where, but I know they do sell it.
You can buy it online.
There are certain things I'll pick up. Like when we talk about cartilage, I've got sharp cartilage pills I can bring in and show you. I got this from Walgreens, so you can get those anywhere. I'm
Yeah.
not gonna run out of files. I'm just curious. Almond
We made
milk.
mac and cheese one time.
You have.
Flavored milk that used to flavor Sean's coffee.
Oh,
Say
no.
some of these milk alternatives, soy milk, almond milk, and other things are supposed to be healthier for you. I don't like the taste of them. Taste is okay. It's just-
Coconut milk is good.
I drink 2%. I don't like skim milk. I like
Whatever.
That's not a
Whatever.
The coconut milk is very good.
It's supposed to be good, but again, that gives them the idea that coconut's really high in fat. But it's a plant fat, which isn't as bad as an animal fat.
Yeah. Or almond milk.
Right, that's what he was asking about.
Oh, man, he got mad.
Minerals, simple inorganic molecules. So vitamins, organic, minerals, inorganic. Molecules required in small amounts, preventing deficiencies, which could result in severe problems. The rest of that definition is the same. Essential minerals, calcium and phosphate for bone construction and maintenance, iron for component hemoglobin, iodine maintains thyroid function, sodium, potassium, chlorine, nerve function, osmotic balance. Where can you get calcium and phosphate?
Salt. Oh no. Calcium phosphate. The herbs.
What? The earth? You're gonna eat dirt?
Yeah. Why not?
Some
Good enough for the worms. It's good enough.
some people crave dirt. I've
Yeah.
read that. Yeah, because of the nutrients in it. They're like craving the nutrients in it.
What's that one show?
Oh, the weird
I don't-
pregnancy cravings?
Yeah.
No.
Yeah. I've never done that, but yeah. Yeah.
Yeah, that's it.
Yeah.
That is some weird stuff.
What is it?
My strange addiction.
Oh yeah, yeah.
Eating bed bugs?
Eating all kinds of
Smoking
stuff.
bed bugs.
Or smoking bed bugs.
Calcium, you can get that from milk. Other dairy.
That's disgusting.
Iron, component in hemoglobin, where you get iron. Meat, beans, things like that. Iodine, where do you get that? Salt, that's the thing you're thinking of, right? Helping you out here. Iodized salt, they stuck a little bit of iodine in their salt. Even if you don't eat much salt,
need
that's
to
enough to
write that
maintain
down.
proper thyroid function. This is something that you hear a lot of times in
Fun
older people where their thyroids get a little off. They have to have surgery on them or have them start taking medications to deal with things. If your thyroid's really out of control, you get what they call a goiter, which is gout and goiter. Huh, interesting. The words are liturgy. It looks like they swallowed like a ring in their neck and it just got caught there. And that's because their thyroid's kind of out of control. Sodium, potassium, chlorine. Sodium you can get obviously from salts, potassium from other types of salts, chlorine as well. Nerve function, osmotic balance. We'll talk more about how this stuff comes into play when we get to these different areas of the body. Stages of food processing. First is ingestion and digestion, two entirely different things. Ingestion, it's science. We can't just say eating. We've got to come up with a big fancy word to compensate for that. In a few seconds, I'll give you another one. Big word for something. Ingestion, it's when you take something and put it in your mouth. That's ingestion. Digestion is the breakdown of food into molecules small enough for the body to absorb. You take the carbs, lipids, the proteins, the nucleic acids, I guess sometimes. Carbs, lipids, and proteins. Stick with that. Carbs are broken down into simple sugars, proteins into amino acids, lipids into the different glycerol and fatty acids. Enzymatic hydrolysis, the breakdown of macromolecules into their subunits using digestive enzymes. If you want to impress somebody, instead of just saying digestion, yes, I'm ready to enzymatically hydrolyze my lunch. Now we'll get you that blood. And then you've got cleaning it, ingestion, I think it's a water bubble.
I'm a receptionist and I do my front office, the KTV, right? And it's a good documentary. Or the office is different documents. The one is on Africa. And it's like a hippo. And like what it does is it gets food on the snout or fish. And then it swims down at the bottom. And the fish also runs out and eats the fish.
Oh wow, it's crazy.
Right?
Yeah. It's not-
Okay, so ingestion, digestion. The other two parts, absorption and elimination. Once you take the food in, once you start breaking it down into its subunits, into its components, Then it starts getting absorbed across the intestinal wall into the bloodstream and taken to wherever it's needed in the body. So cellular uptake of small molecules by the digestive system. We're going to get into details about that before we get rid of this chapter today. Elimination, passage of undigested material from the digestive system. Yes, the king of beasts, taking a squat. I mean, it's not like I'm going to show a person on the toilet. That's just wrong. So it kind of amused me, the king of beasts. Everybody's got it. Passage of undigested material from the digestive system. So that stuff that we can't digest or the body doesn't need and won't digest, that stuff is what's going to pass out of us. A lot of plant material. We can digest it in part because of the bacteria living in our guts, but we can't digest it completely, so that's what is eliminated from our bodies. One of the things we can't digest. If you keep loading up on the same type of food, your body gets plenty of it, it doesn't need any more, it's just going to keep passing on through. So passage of undigested material from the digestive system. Okay, before we get to the digestive compartments, let's go ahead and take a break. Be back here at 10:30. And that's what's next. Hydrolytic enzymes released outside of cells within a compartment continuous with the exterior. In English, what that's saying is you put food in your mouth, you swallow it, it goes down the esophagus into the stomach. And that's where a good chunk of our digestion occurs. So we've got all these cells in here that are releasing hydrolytic enzymes into the space, into the lumen or the opening of the stomach. And they start to break things down there. Remember, your stomach, by way of what the esophagus and mouth, is continuous to the outside. So put it inside of us. The cells do not absorb the food to be digested there. Later they will absorb the nutrients in another part of the digestive system. But in this area, they use the lumen as the chamber where digestion is to occur. They release their enzymes outside of the cellular body into the lumen or the opening of the stomach. This way it allows for larger prey or more food to be digested. Okay.
Would flies qualify for this, or at least the first part of their digestion?
Most of what they do is they release it outside their mouth and then they reabsorb it like that. So I don't know, I'm sure they would have some type of extracellular digestion inside, but they absorb instead of ingest. So part of the digestion takes place outside, but all the nutrient absorption and everything would have to take place on the inside. So some of it, it's both. Outside their body and inside their body. So take a lion, for instance. It's hunting in Africa. Maybe it's been a few days since any prey have been found or actually successfully taken down. Herd of zebras goes through. There's one in the back that's just kind of limping along. Injury, age, whatever the case might be. The lions take it down. Now, if they couldn't even figure prey, then obviously that would be out of the question. They'd have to go for something smaller. Larger prey, and they will eat and eat and eat to the point where they get bloated from all the food. They don't know when the next herd is coming along and if they're going to have success in capturing a zebra, so they eat as much as they can and then some. They might spend a couple of days sleeping, trying to sleep it all off because they're just too big to get out, go anywhere, do anything. Kind of like you after Thanksgiving.
Or dinner.
Or dinner in general. The gastrovascular cavity, the digestive sac, is one opening that functions in digestion and absorption of nutrients throughout an organism. The case for this, the organism has to be itty bitty, very, very small. So you look at this. Here's the mouth right here with the tentacles around this. This is the hydra that we saw. The food goes in here. It's broken down in here. Whatever is not digested goes back out the same way. What's broken down is absorbed through diffusion across from the gastrovascular cavity into all the cells. Now, this guy is only about 2 or 3 cell layers thick. That is it. Diffusion works ideally for him. But see, we're too many cells thick for diffusion to accurately work throughout the entire being of us. So we have to break things down and use the circulatory system to get nutrients to where they need to go, and then at their destination, then you might see a little bit of diffusion going on. So the gastrovascular cavity, digestive sac with one opening that functions in digestion, and absorption of nutrients throughout the organism. One cavity does it all. A couple of the terms for mammalian digestion, which is what we're going to be focusing on most of the rest of the way through here. Peristalsis, rhythmic waves of contraction by involuntary smooth muscles in walls of tracts, like the digestive tract. You don't really have to do much with regard to digestion. You have to find something to eat, put it in your mouth, chew it up a little bit, then swallow. And from there on out, it's on automatic pilot. And one of the ways you move the food through is by these involuntary smooth muscles. Just kind of squeeze it, like putting your hand over hand over hand, pushing something down through the tube. If you want to see peristalsis in action, watch earthworms move and some snakes move by the same manner. There's a rhythmic wave contraction going from one end to the other. A sphincter, you might have heard of these before, usually associated with one part of the body. Actually, you have sphincters all over your body. You have them throughout the digestive system. A ring-like valve that regulates passage of material between specialized regions of the tract. This is to ensure what?
One way.
Absorption.
One-way
Oh.
movement. Make sure the food moves one way and doesn't come back. You have sphincters in your blood vessels to make sure the blood keeps flowing in one way so it doesn't backflow. So you find them all throughout your body. So again, peristalsis, this wave-like motion that pushes food through the digestive system. You see it in the esophagus, you see it in the intestines. And the sphincter is to make sure that food keeps moving in the same direction. It doesn't go backwards. The oral cavity, where food is mechanically and chemically broken down. Digestion literally begins in your mouth. You start chewing stuff up, and it starts breaking it down physically. And then you have digestive enzymes that are even released in your mouth, one of the main ones being salivary amylase, that starts breaking down starches. Also in your mouth, you have saliva, which contains the digestive enzymes like salivary amylase, mucin, which protects the mouth lining from abrasion, and lubricants to make the food easier to swallow. Look at it this way. If you didn't have saliva, think about what it would be like eating potato chips. It'd be like chewing and swallowing glass. It would cut, it would hurt, it would not be pleasant. Everything would be like Jell-O or pudding, and that would be about it. How boring. So saliva helps to moisten stuff, helps protect the lining of the mouth, so you don't cut your mouth up every time you eat something with a sharp edge. You also have buffers to neutralize acids and antibacterial agents to kill germs. You have lots of bacteria in your mouth. Even if you just brush your teeth, even if you're very hygienic, very careful, you still have lots of bacteria in your mouth. Some of it's there just to hang out. It doesn't do us any harm one way or the other. Some of it is actually beneficial. We'll talk more of that beneficial type bacteria as we move through the digestive system. You have literally hundreds of bacteria. I don't mean just individuals. Hundreds of species of bacteria living on or in you. And like I said, most of it's there, not a big deal. So the oral cavity, where food is mechanically and chemically broken down, mechanically by teeth, chemically by saliva. Saliva contains digestive enzymes like mucin, which contains digestive enzymes, mucin, which protects the mouth lining from abrasion, and lubricants to make the
If the chemically broken down with the saliva, what does that have to do with the way you taste it? Like I taste it.
I don't know. I think that one of the sons. Awesome.
Yes.
For the chemically broken down, would that also have to do with like our taste and our taste buds?
Not so much. That's when we break down the food, the taste is a byproduct of that.
Okay.
We'll talk about that in a second. Okay, here's the mouth, mammalian digestion. I didn't want to put a human's mouth up there. I really respect and appreciate people who decide to become dentists and dental hygienists. I could never do it. That's right up there with working in a shoe store. Forget it. Certain parts of the human body I could rather leave alone. Okay, you have the upper teeth, the bottom teeth. You have the soft palate on the back, the hard palate in the front. You have all this stuff. How many of you are using your tongues to find the hard and soft palate right now? The opening to the pharynx, which we'll talk about, the tonsils in the back that some of you may or may not still have, the tongue, which we'll talk about. What's the frenulum?
The thing underneath the tongue?
A little
What's
wet.
the purpose?
Keep your tongue in the mouth.
It attaches the tongue to the floor of the mouth. The frenulum.
I heard if you cut that, you'll die, you'll bleed out.
You'll swallow
Swallow
your
your
tongue.
tongue.
I don't know. I don't think you bleed to death from that. I don't know if you'd swallow your tongue, but it'd make it a lot more loose, and you have to be more careful every time you swallow.
Some people cut it to make their tongues longer.
Okay.
That's
Yes. And I think that's about it. So let's talk about the tongue. Taste manipulates food while chewing, shapes it into a ball, but again, it's science. We can't call it a bowl. It's got to be a bolus. Push the bolus to the back of the mouth prior to swallowing. Next time you eat, kind of pay attention to what your tongue's doing. Drive you nuts. You're sitting there, kind of shaping the food, getting it just right, and sending signals to your brain. You're subconsciously thinking, yeah, it's still too big. Can I swallow? It's getting there almost, and your tongue kind of forms into the shape, and then you swallow, and it's gone. You got nothing else you have to worry about for digestion until you're done at the very end. On the tongue, you have papillae. This is actually what the surface of your tongue looks like. When you look at it in the mirror, it looks very smooth. But if you were to blow it up like this is what it would look like. All these finger-like projections. Why all these finger-like projections?
And taste buds.
This is something common you see in nature. It increases surface area. It increases surface area. As opposed to just being flat and smooth, increases surface area, gives a little bit of traction. And then this is where your taste buds are located too. Yes?
When you get sick, how come your tongue has a tendency to get coated?
I don't know. It's been a long time since I've been sick like that. There are 5 regions for taste. Sweet, sour, salty, bitter, and umami. That's the newest one.
What is it?
Umami.
What is it?
Kumami.
Umami. U-M-A-M-I.
Umami.
It was discovered by Japanese scientists, and it's for delicious. I kid you not. Seriously, look it up. You don't need to know the 5 regions, but that's what they are.
Umami.
Sweet,
That's not gonna
sour,
be a
salty,
multiple
bitter, and
choice.
umami.
Umami. Delicious.
Next stop on our tour through the digestive system is the pharynx, junction that opens to both the esophagus and the trachea. The opening itself is the glottis. The epiglottis covers the glottis when swallowing. It's kind of like traffic control. Am I swallowing air or am I swallowing water? Am I breathing in or am I swallowing food in? You know, when you eat too fast, you start to swallow something, you start to choke. And oh man, that almost went down the wrong way. Well, you've got 2 tubes right there in your neck. You've got the esophagus and the trachea. Trachea leads to the lungs, the esophagus to the stomach. It starts going down the wrong one. There's what you're eating. That could be a very bad thing. So you start to cough to bring it back up. You don't want food and water going down into your lungs because that could create a bad situation. It can cause contamination, it can cause things like bronchitis, pneumonia, stuff like that. You don't want it going down there. So the epiglottis covers the glottis, a little hole. So when you swallow, it goes down the right area. So the pharynx junction that opens to both the esophagus and the trachea. Right here, the trachea in the back, the esophagus in the front.
Is that like the little flap that opens and closes? Yeah.
Next up is the esophagus. Conducts food from the mouth to the stomach by peristalsis. Swallowing is voluntary. There are striated muscles. When we talk about muscles, we'll talk about this tomorrow. Which are the voluntary ones, which are the involuntary ones. The striated muscles, skeletal muscles are voluntary. So you get to decide when you're ready to swallow. You don't think about that much because you've done it so many times in your life that it's just one of those patterns that you just go about without even thinking about. However, the rest of digestion is involuntary, controlled by smooth muscles, which are almost all involuntary. So once you swallow and it starts heading down, smooth muscles take control to get to the stomach and then move on to the rest of the region. Yes?
So like when someone has a brain injury and they can't swallow anymore, is that the flap that's not working correctly, or?
No, it's the signals going from the brain to that area.
Oh.
You have about 13 nerves, I think, going
Oh.
from your brain to everything in and about the face and the head. Okay? And it controls that. So if it's an injury in that area, it could affect the ability of the person to swallow on their own. There's certain diseases that affect that. Lou Gehrig's disease, amyotrophic lateral sclerosis, ALS is also one that will affect a person's ability to swallow. So, yeah,
Could a stroke do that?
yes. Depending on what part of the brain it hits, but yes. And of course, when you get down to the very end of digestion, you have control over it again. We'll talk about that when we get there. Stomach, site of continued digestion and food storage. It starts in the mouth, continues in the stomach. Food will be held there for a little while. You can actually stretch to accommodate 2 liters of food. Think about a 2-liter container of soda. Your stomach can hold that much. Secretes gastric juices, pepsin, and hydrochloric acid. Okay, gastric juices, all right. Pepsin, that's an enzyme, one of the few that don't, and an ACE. And then hydrochloric acid, giving you a pH of about 2 in your stomach, 2 to 2.5. This is why when you get sick, when you vomit, when it comes back up, it burns. It's that acid coming up your esophagus. That's why it leaves the bitter taste in your mouth, because the hydrochloric acid is kind of like a bit of a rotten egg type taste or smell. When people get acid reflux, indigestion, heartburn, it's all pretty much the same thing. What's happening is something's causing the fluids in the stomach, the gastric juice, pepsin, hydrochloric acid, to leak back up into the esophagus. Maybe it's a bad bowel. Maybe you laid down after you ate, some of the food came back up this way. You ate too much and pushed some of the food back up. And that's what creates a problem there. Because we're going to talk in a second about how the stomach has a protective lining, but the esophagus doesn't. And so that's why it burns, why it hurts when it comes up through the esophagus, and why it doesn't affect you so much in the stomach.
Is there a valve right there that
Yes.
so that's why it can come up sometimes, right?
Yes. Yeah, I think we'll talk about one of the valves, not both.
Yeah.
Now, in case you haven't thought about it before, how can you eat a burger or a steak or something that is very meaty and you can digest it, but your stomach does not digest itself? Think about that for a second. Well, your stomach has things going on to help prevent self-digestion. First of all, delayed activation of enzymes until in the lumen of the stomach. So here are the stomach lining cells that produce the enzymes, and here's your stomach with this big opening in the middle. Okay, it's a hollow organ. Think about it like fireworks. You can set fireworks off on the ground. There's no that ooh-ah factor, and you could set the ground on fire. You put them up in the air, everybody can see them, and you don't have to worry about catching the ground on fire. Well, that's what happens here. The enzymes are launched like fireworks into the central part of the lumen, into the open area of the stomach, and that's when they're activated. Not on the surface of the stomach where they could actually burn through the stomach, but into the open area. Also, secretion of a mucus coating from stomach lining cells. Secretion of mucus coating from stomach lining cells. So these cells are going to secrete mucus to help cover them, protect them against the acids. But nothing lasts forever. Those cells are going to wear down. I don't know if you remember, but I've told you before, you've got high traffic areas of cells in your body. Skin cells, because they're constantly being sloughed off to protect our outer surface. Red blood cells, because they're constantly on motion, picking up oxygen from the lungs, carrying it to all parts of the body, dropping off the oxygen, picking up carbon dioxide, bringing it back to the lungs. And then lastly, the stomach lining cells. Because these cells are under constant attack by a highly acidic environment. And even the best cells can only last for so long, secreting mucus to cover them, protect them. Eventually they wear out, they give out. So mitosis is highly active here in the stomach, constantly replacing those stomach lining cells. So 3 different ways the stomach protects itself. It could be multiple choice, it could be short answer. I would learn the different ways. End result, you have a nutrient-rich acidic chyme that is produced. Chyme leaves the stomach and enters the small intestine by way of the pyloric sphincter. So here's a sphincter right here. It's called the pyloric sphincter. I believe this is called the cardiac sphincter because it's closer to the heart. Pyloric sphincter, it's closer to the small intestine. Now, sometimes people get ulcers in the stomach. That would be understandable for some reason. Usually people that are highly stressed might produce more enzymes, more hydrochloric acid than the stomach can tolerate, and it starts eating away at some of the sides of the stomach. They can be very dangerous, can even lead to death. So exercise, be calm. You can also get ulcers in this part of the small intestine called the duodenum or duodenum, and they're known as duodenal ulcers. Yeah.
If you had the sphincter up above, like higher up, would you still be able to throw up?
Oh yeah. It's just that whatever's upsetting the stomach so much overwhelms the sphincter and forces the food back up. Let's say you got some bad fish or some bad chicken, and you get food poisoning. It's bad for your body, and your body's going to try and eliminate it from itself. So that's what it does. And eliminate it, and eliminate it, and eliminate it until it's all gone.
If you get a gastric bypass, those regenerative cells still act the same way, or
I would think so, but maybe just not as actively,
Oh.
because if they're not being subjected to things going on in here as much,
yeah,
then they wouldn't be needed as much.
yeah, because it's
So
like
your body should compensate for that.
it's like healed cells, so like they're like chopping the stomach in half.
Or whatever they do with the gastric, bands or whatever they put around the stomach.
Yeah. Okay.
Next up is the small intestine side of enzymatic hydrolysis of macromolecules and absorption of nutrients into the bloodstream. So you eat that Big Mac from McDonald's, and it breaks it down to the proteins, the carbohydrates, and the lipids that make it up. Now, the small intestine is going to take the carbohydrates, lipids, and proteins and break them down even smaller into the simple sugars, the amino acids, and the glycerol and fatty acids. It can be up to 6 meters long in humans. How many feet is that approximately? 18 to 20 feet long. It's huge. This is the site of most nutrient absorption. I'll show you how it does that in a second. It has a large surface area, about 300 meters square. If you took the small intestine and exposed all that surface area to a nice flat surface, it would come close to covering an entire tennis court. That much surface area. Question?
Why does it need to be so long?
We'll talk about that towards the end. Short answer real quick, so we can absorb more nutrients. The longer it is, the more nutrients you can absorb. So it makes eating more efficient for us.
And what determines the length?
Diet. I mean, we're pretty much set. It's not like you can go on a diet and your small intestine is going to shrink, or if you always watch what you ate, your kids are going to have short small intestine. It doesn't work that way. I'm talking about like different species. If you're an herbivore that feeds on grasses and leaves all the time that aren't real nutrient rich, you're probably going to have multiple chambers of a stomach. You're probably going to have a longer intestine to try and absorb more nutrients. But if you eat a very nutrient rich diet, you wouldn't need such a long intestine. Yes.
People that are like extremely obese get that surgery, they get like whatever their purpose of stomach, something else removes,
Uh-huh.
they lose weight. How does that affect them like, in the long term? They take part of that.
It shouldn't affect them adversely in any way, but a lot of times people that do that, I've known quite a few people that have had that done, tend to put the weight back on. Because what they've done is they've made a change to the physical body, but if you don't change your behavior to the mental part, if you don't diet, if you don't exercise, it's not going to do any good. It's just a stop. So usually they just don't have any long-term effects because people just put the weight right back on. Right, so they compensate for it. Because their eating habits never change. Okay, how do you get all that surface area out of what looks like a tube? I mean, if you take the small intestine, slice it, and look at it, it looks like a garden hose. Look that smooth inside. Now, if you slice it and put it under the scope, more surface area becomes apparent. First of all, you have villi, which are finger-like projections into the lumen of the small intestine. So all these finger-like projections are around the outer edges, it's just that we can't see them. And then on top of the villi, we have microvilli, microscopic finger-like projections on top of the villi. So here are the villi extending into the lumen of the small intestine, and you see what looks like a little fringe on top here. Those are the microvilli. Here it is with the villi, or the villus, only one, and then you see the microvilli all on the surface of this. It's inside these villi that we have our blood vessels, and so the nutrients are going to be absorbed across the wall of this and enter the bloodstream. So the villi and the microvilli. This is what increases surface area in the small intestine. This is what gives you enough surface area to cover a tennis court. Also here, look at all the different tissues involved. We've got epithelial lining the small intestine. We've got muscle layers, smooth muscle layers around it, pushing the food through by peristalsis. We've got connective tissue in the blood vessels around it. So you see a lot of tissues coming together to help you digest food. Lacteals are small lymphatic vessels that, along with blood vessels, penetrate the body in order to absorb nutrients. Okay, the blue and the red are the blood vessels. The yellow is the lacteals. And most of the food that's absorbed across the wall of the small intestine is taken to the liver for processing. And then it's figured out where to go from there. Your liver is very highly vascular. If you ever dissect an organism recently killed, like in research or something like that, don't cut the liver, don't cut the spleen. It will bleed and bleed and bleed. Doesn't mean you don't want to cut his digestive system, it'll just stink.
The lymphatic vessels, do they have anything to do with like your lymph
The
nodes?
lacteals. No. Yes,
Lymph nodes?
indirectly.
Directly?
Indirectly. Basically, the lymphatic system is something that will collect things and drain them to the appropriate parts of the body. Mostly fluids, but in this case, nutrients. And then the lymph nodes are tied into that. We'll talk more about that when we get to immunity. Next up is the pancreas. Now, everything we talked about so far, food has passed through. From the mouth to the esophagus, the stomach, into the small intestine. Food does not pass through the pancreas. It's one of these accessory digestive organs. So it doesn't make a trip through the pancreas, but the pancreas contributes. You see it pretty much in the middle of the body. When we dissect the fetal pig, you'll look for the pancreas. You find it in that first fold of the small intestine, in the duodenum region or duodenum region. So when that small intestine comes out of the stomach and makes its first turn, that's where you find the pancreas. What it does is it produces hydrolytic enzymes and bicarbonate that act as buffers to the acidic chyme. So as soon as the chyme leaves the stomach, you've got the pancreas sitting right there trying to neutralize it before it passes through other parts of the small intestine because it's coming through too acidic. So the pancreas is an accessory organ that helps out. Now, you're probably more familiar with the pancreas with insulin production. Okay? But it also has another function as the buffers for the stomach. Another organ that food passes by but not through is the liver. It produces bile containing bile salts that act as detergents or emulsifiers, which aid in the digestion and absorption of fats. Again, it goes back to the idea you're waxing your car or you're baking in the kitchen. You get wax, grease on your hands. You can't wash it off with the water until you put some detergent, some soap on it, and then it breaks down. Well, the same thing in your body. That's what bile salts do. They help you to emulsify or break down fats. The hepatic portal vein is a vessel where capillaries and veins carrying nutrient-rich blood from the villi converge. So like I said, everything passes basically through the liver. A little bit of storage there, a lot of filtration. Now, like I mentioned with the frog, and like we'll see when we dissect the fetal pig, as it is in humans, the liver is an enormous organ that you see sitting, basically separating the thoracic from the abdominal cavity. It's the barrier between the two, basically. Actually, the diaphragm is, the liver sits right under the diaphragm. More on that later.
So does the liver get bigger because it produces those bile salts? Like, say if you were like doing drugs or drinking alcohol, like is it producing more of those bile salts, so it's getting bigger because you're doing this?
You can enlarge it, but eventually the liver will only get to a point where it can't do anymore, and that's when people who tend to abuse alcohol and drugs develop a condition such as cirrhosis of the liver or liver cancer.
Okay.
Cirrhosis of the liver just starts breaking down. It's like it's done. Hepatitis, which is a liver viral infection, can also bring about cirrhosis of the liver as well.
Doesn't the liver grow back though?
It can regenerate itself, but if it's been abused for a long period of time, even then, it can't regenerate itself. You can be a liver donor and still survive, like a heart donor.
Yeah.
But you can't be a liver donor. We'll cut out part of your liver because it can regenerate. 505. Remember we talked about the liver and mitosis? That it will regenerate to a certain point and then stop until it needs to regenerate again.
Is it the only organ that can do that?
Off the top of my head, yes, for right now. Yes? I've never heard of that. I know people who have. absorption, along with small intestine, absorbs approximately 90% of water that enters the digestive tract, up to 1.5 meters long in humans. If this is shorter, why do we call it the large intestine? Bigger what?
Girth.
Girth, okay. Maybe bigger circumference. Diameter. It's got a larger opening. That's why it's called the large intestine. Small intestine's got a smaller opening. So even though the small intestine's longer, the large intestine has a bigger opening. 1.5 meters, how long are we talking about?
3.
4.5 feet.
Yeah. I like watching you try and do math. You can just see the
It's
wheels
not big.
turning. About 4.5, 5 feet long. Now, you notice that the large intestine comes in off the small intestine, pretty much frames the area where the small intestine is found. You have the ascending, transverse, and descending that'll go into this part where we'll get to next. So if you look at small intestine, mostly absorbing nutrients, large intestine mostly absorbs water. It's also the site of feces formation. Become more solid as they move through by peristalsis. It takes about 12 to 24 hours to cover the length of the colon or large intestine. Just what you want to be talking about right before lunch, right? Formation of the feces. Your large intestine is home to many bacteria, oftentimes found in feces. One of the big ones is E. coli. Now, most of the time you probably associate E. coli with food poisoning. Well, how do you think it gets there? Why do you think all the signs are posted in the bathrooms of restaurants? If you use this, please wash your hands before you go back to work. The E. coli can feed on unabsorbed organic material. Byproducts include methane and hydrogen sulfide. These are part of the methanogens we've talked about. But they also produce vitamins. So there is a benefit to having these in our digestive. So home to many bacteria found in the feces. And the big one is E. coli.
Is that why it stinks so much?
Why what stinks?
That's
Feces.
sulfur.
Feces.
Sulfur.
Feces
It's because of this stuff?
or when you have gas, that's why it smells like it does.
Is it because of the E.
They're
coli?
producing methane and hydrogen sulfide. Methane is natural gas, and hydrogen sulfide smells like rotten eggs. So yeah. So if you eat something like a lot of beans or something else high in fiber, the E. coli are working overtime. So yeah, they're going to produce extra gas, and so will you. Viral bacterial infections irritate the lining of the small intestine, reducing water absorption, resulting in diarrhea. If the feces move through too slow, too much water is absorbed, it results in constipation. So, it all depends on how fast the feces move through the large intestine. If you've got some kind of bacterial infection going on, they're going to move through really fast. So not enough water is absorbed, and it comes out very, very runny because it's got a high water content. And this is why you really have to watch people with diarrhea, especially young kids, because they could dehydrate because they're losing so much water to their feces. Now, if it moves through too slow, then too much water is going to be absorbed, and it's going to create constipation, almost a type of blockage, because the fecal matter is too hard, too firm. It's not pliable enough to continue to pass through, and that could be a problem as well. So everything has to move through at just the right rate to remove just the right amount of water in order for everything to work naturally and normally. Okay, one more we'll stop. The rectum. Endpoint of the colon stores feces until they can be eliminated. You have two sphincters in the rectum. One is voluntary, the other is involuntary. This is where you gain control or regain control of digestion. And you can determine when it's time to eliminate waste. If you wait too long, then you might lose the control again, and the body will decide when it's time for you. So that's the idea of the voluntary and involuntary sphincters. If everything's working normal, if you have a time at which you can eliminate the feces once you complete the digestion, then everything will work out fine. But if you can't eliminate them, then what might happen is the body decides when it's ready to eliminate for you because it's got more fecal matter on the way to be stored in the rectum. Did I say that, Tilly? And so the circle part is the rectum. That's where everything kind of hangs out and waits. Okay, while you're finishing writing, what I want to do is pass a few slides left and we get into circulation and gas exchangers today. Okay, dentition. When we talk about dentition, we're talking teeth. A couple of different types of teeth we find in different organisms, and it has a lot to do with their dietary styles. First up are homodont teeth. Teeth that are identical in shape, used for grasping and swallowing prey whole. These include things like fish, amphibians, reptiles. They bite a couple of times, they position the food, and they just swallow it down. They don't do a lot of chewing. There's not a lot of digesting things, not in the mouth anyway. That's all done pretty much now in the digestive system itself. What I don't want you to tell me if I ever ask you about this, teeth are identical in size. They are not identical in size. They have different sizes, but they are identical in shape. For something like the alligator here, it's all going to be that conical or cone-shaped tooth. Okay, and you see they are different sizes. Dont refers to dentition. Hollow means the same or similar. Same or similar to dentition. The opposite, yes.
How does their tongue work?
How does it what?
Their tongue. So like, is their tongue different?
It's not going to be as articulate as ours. What it'll do is it'll just help position the food to be able to swallow it whole. Taste, not a big thing. It's more for quantity, not quality. Heterodox teeth are different in shape, not in size, but different in shape. Used for tearing and chewing, breaking food down into smaller pieces. This includes incisors, bicuspids. In some animals, we call them canines, molars, or in some animals, we call them carnassials. We will look at different skulls towards the end of the semester and see these different teeth in lab. The only example here are mammals. What's noticeably absent are birds because they have no teeth. But I bet somebody in here will put down birds as an example of a heterodon or homodon animal. It's happened before. And it makes me laugh so much when I see things like that. And the other professors too, with whomever I shared. I said, are you serious? These are your majors? Really? Birds? Anyway. So hetero means other or different shaped teeth. Now, if I were to ask you to distinguish, you don't have to write all this stuff down. Heterodont, different shaped teeth, maybe the function. Homodont, same shaped teeth, function. And there's just an example of each. You don't have to give me multiple examples, just one of each. I know that you know what you're talking about.
Did birds ever have teeth, or?
Maybe a long time ago, they were in transition from dinosaurs. But they lost those, they didn't really need them. Made them a little bit lighter, not having teeth. But birds are all about efficiency for flight. Other evolutionary adaptations, the digestive system, expandable stomach in some animals allows for more ingestion at one time. Next meal, unknown. That's not us. Ours holds up to about 2 liters. That's about it. You can try and stuff yourself and eat more. It may stay down. It may spill up because you put too much in there. However, some organisms have the ability to eat and eat and eat because if your lion's chowing down on a water buffalo, you may not find another water buffalo for days or weeks at a time. So you fill up this expandable stomach more than it can really hold because you don't know where your next meal is coming from. Next meal unknown. Also, an elongated intestine creates more surface area for more absorption of hard to digest plant material. So longer intestine allows for the ability to absorb more nutrients out of something that is relatively nutrient poor. Yes?
So part of the stomach expanded, isn't that also called the primordial pouch when it comes to cats?
I've not heard that before. I'm not a big cat person, so it's not surprising.
Yeah.
I just look at it as, oh, that's flabby catty. I don't know if that has so much to do with the fact that it's a stomach, and it could be because, I know that, or if it's more that it's just cats that have given birth and it just didn't retract. Multiple births. So we've got homodont, heterodont teeth, expandable stomach, elongated intestine, and symbiosis. Animals such as herbivores, owls, methanogens which contain enzymes to assist in breaking down cellulose. We have bacteria living in our guts that help us to break down hard to digest plant material. Without it, we couldn't even begin to do it. Location of symbiotic bacteria in the digestive tract varies from species to species. So it depends on where you do the greatest amount of your digestion. Obviously, the stomach would be too acidic for organisms to survive there, but they do pretty nicely in the small intestine to help break down some of that hard to digest plant material. Obviously, herbivores, cows eating grasses, anything eating plant material, including humans, are a little bit omnivorous. Even things like termites that work on wood. Okay, they've got the mouth parts, they can break the wood down into smaller pieces. They can never begin to digest it without these symbiotic bacteria